Hello, David.
Hello, finally.
So we're starting in about a minute. Just wanting to check if you can hear me all right, see me all right.
Loud and clear.
Yeah. Good. You're on mute, but doesn't matter. But if you do want to say something, you have to unmute yourself.
Why am I muted?
Yeah, you're mute. You're muted, but I can't see the. Where's my audio is maybe muted. Can you say something?
Hello, hello.
Oh yeah, wait, I do hear you. Oh, guys, tech. It's all something. That's the biggest challenge for tonight or tomorrow or this afternoon, wherever you are. Is making sure that everything works. But we'll get there. So I see lots of people coming in already. I'll give it 1 or 2 minutes before I will start the introduction to this workshop, Shiny 101, the modular app blueprint. In the meantime, I want to have a poll, a question in the chat. So on the right, to kind of see where you all at with your Shiny knowledge. David, if you want to do the honors of putting the poll in there, just to see what your experience with Shiny already is, and then I can kind of determine how fast or slow I need to go over some subjects. And feel free to say hello in the chat. There's also some other messages in the chat already. For example, where you can find the GitHub repo for this workshop. I will highlight that message right now. Also to fork the repo and to have access to the slides, which will contain examples, and then you can easily copy and paste stuff. Hello, everyone.
Villa, I don't seem to see this link in the message.
Not? With my highlights message?
I apologize. I see it.
And the URL to the repo is also in the slides, so don't worry if you missed this message. But I'm going to start. Did you create a poll already, David?
I see. Apologies.
Yeah, there's a poll section as well. Good. Joanna says the link works, so all good. Right, I see lots of people. Hello from Berlin. Oh, that's close by, relatively close by. Ireland, Brussels, that's closer by. I'm in the Netherlands, by the way, so that small country where it's always raining. Lisbon, oh, it's more sunny there than in the Netherlands. San Diego, Canada, Norway. Oh, I love Norway. Beautiful country.
There we go. I've put a poll into the poll section.
Great. So as you can see, there should be a pop-up window saying there's a new poll. If you want to answer that for me, to kind of get a sense of how familiar you are with Shiny, so that I can see, if I should tailor my content. Already lots of people voting, some beginners I see, intermediate, not many advanced. That's good because this is a beginner workshop. But okay, I'm already getting a sense here. I'm going to share my screen and I'm going to start with a little introduction. So where? Share screen. Right, and you should all see it now. Great. So welcome to this workshop, Shiny 101, the modular app blueprint. And in the coming 2.5 hours, I'm going to teach you the basics of Shiny, and hopefully you will walk away with knowledge on how to build your first Shiny application and how to work with Shiny modules. So welcome. First, a little bit of introduction so you know who is talking to you, and David will also introduce himself because he's helping me out today with the workshop and answering all kinds of questions. My name is Veerle van Limpet. I am an R and Shiny consultant and trainer. I'm the director of Hybride, a company that gives R and Shiny training and workshops, and I've been programming in Shiny for about 6 to 8 years or something, and have developed a lot of Shiny applications already. I absolutely love it. It's easy to start developing applications and also really bring your analysis to life, let people interact with it. And I really love it about that. I'm also doing a lot with JavaScript and package development. And yeah, I'm sure you will hear more about me later on as well. David, do you want to give a quick introduction?
Yeah, sure. So hello, everyone. I'm David. I'm an R Shiny developer at Absalon. I've only been there for about 3 or 4 months now. But prior to that, I was building R Shiny apps at Unilever for a bit. And yeah, so that's sort of my experience of R Shiny. But given that I am the less experienced one here, I will just be the assistant helping out with queries or any questions that pop up in the chat. So feel free to send those through, and I'll do my best to help move things along.
Perfect. Thank you, David. I'm very glad that you can help me out. Today, we have around 165 people here right now. So if everybody's going to ask a question, then there will be a lot of questions to be answered, and I can't do that all by myself. Okay, that brings me to, I guess, a little bit of the program, what we're going to do today, and some workshops, etiquettes, I call them, or kind of how we are going to do this. So this is my time. For you, it might be a different time, but this is just for me to make it easy. It's quite late here already, so I'll also be probably going to bed straight after this workshop. The first half hour we will spend on an introduction to Shiny. This is really covering the basics because I see that there are quite a lot of beginners as well. So we're just going to start basically from scratch. Then we are going to build a Shiny application together, and how we're going to do that is you're going to program with me. Since there are a lot of people here, I'm just going to code and you can follow along by forking the GitHub repo that I have and just following me step by step. I'm going to go really slowly so that you can follow along and really get the sense of building the application yourself. So that's the hands-on part. During the hands-on part, if you have any questions, you can ask them in the chat. You can also join us on stage if you want to. If you want to ask your question there, that would be super fun. And then we try to make it a little bit interactive that way. Then we have a short break, so then you can grab your coffee or, I don't know, depending on the time, your beer or your wine or whatever you want. And after that break, we are going to start with an introduction to Shiny modules. So this is already getting a bit more advanced. We're going to talk about what a module is, how you're using it, how you can make nested modules, how you can share data between modules. So quite deep into modules already. And then later on, we're also going to implement that in the application that we will be building during this workshop. At the end, we have a little bit of time for any questions that might have arisen but didn't get an answer, or anything that you want to share about this workshop, or what you think of Shiny and what you find difficult or easy, or basically some chatting. And then we'll do a quick recap before we close off this workshop. Any questions so far about that, or all clear? I guess this is still the easy part, so I think it will be fine. As you can see, again, the message is pinned for the GitHub repo in the chat section, so you can access it there. While I'm talking, you can already start forking that and perhaps install the necessary packages. It's not many. Shiny and bslib are the most important ones if you don't have it already. Okay, good. So I hope you will walk away with all the knowledge that you need to build your first Shiny application. And after this workshop, you will know what a Shiny app is, how to make it modular, how to communicate between the modules. And I will also give you some templates that are available in the GitHub repo and that I will explain during this workshop that you can use later on to get a quick start on your next Shiny application. Right, introduction to Shiny, that's what we're going to start with. Just that I didn't forget to mention it, when it comes to level of Shiny, if you don't know about Shiny or haven't heard about Shiny at all yet, no worries, we're going to start from scratch here. If you did already, well, then you can also listen, but you will probably know a couple of things in a bit, but don't leave the workshop yet, because I will also go quickly deeper into what an app is, talking about the difference between observers, reactives, reactive values. So there's here something for everybody. And we're starting super simple, namely, what is a Shiny application and what are the parts of a Shiny application? A Shiny application has two parts, the UI, which stands for user interface, and the server. And together we put them in a script that we call app.r. So it's just an R script that you make with the name app.r. Still simple. If we're going to look at this app.r script, then we're seeing that we need a couple of ingredients here for a Shiny application. First of all, we need to load the Shiny package. Makes sense. So we just call library Shiny. Then we start building the first part of the app, which is the UI. As you can see here, the UI always, well, you see that here, but a UI always starts with a fluid page, so kind of a wrapper wherein you put all the content that you want to put in your user interface. Then we have the server part. Server part is a function that takes 3 arguments, input, output, and session. And then the last thing that you need for your app.r script is the Shiny app call, which is a function that builds this UI part and the server part together. So looking a bit more closely at the UI part, I already talked a bit about fluid page. The fluid page creates a bootstrap page. It basically tells the web browser, hey, I have here a web application that I want you to display. Bootstrap is used throughout the web, and probably a lot of websites that you have visited were built using Bootstrap. It's free, it's a front-end framework that is used in web development, and it basically includes everything that you need to build a web application. Bootstrap is built with HTML, CSS, and JavaScript, and that is exactly what a Shiny application is as well. It is a combination of some HTML, some CSS to make it look pretty, and some JavaScript to make it do stuff. But we're not necessarily HTML, CSS, or JavaScript developers. We're R developers, so what Shiny does, it kind of puts all kinds of R functions on top of this HTML, CSS, and JavaScript so that you don't have to think about it. Shiny is based on a certain version of Bootstrap, namely version 3 of Bootstrap. The latest version of Bootstrap is Bootstrap 5, so you might already have the question like, hey, why doesn't Shiny use the latest? Well, that's quite a technical question to answer right now, but there are ways to make your Shiny app compatible with a later version of Bootstrap, which we're going to talk about a little bit later. So if we're looking at the UI part, then basically everything in the UI is translated to HTML, one of those 3 things that we need for a web app. As you can see here, I have here a simple function which is called title panel, and it is part of the Shiny package. Well, if I would print that out on the console, I wrapped it here in a simple as character, then you can see here that it prints HTML. So it has this H2 tag, we call it, which stands for a certain size of a header, and then it prints the content out there. This is true for every function that you put into your UI. It all gets translated to HTML. Sometimes this HTML can also have different styling attached to it in the form of a styling attribute, so style attribute, or a class. So in the second example here, I have the sidebar panel, which is also part of the Shiny package. And if we translate or print that out on the console, we also get some HTML, which is made up out of a div. It's basically an HTML container. And in that we see a certain class, which is here called col SM4, whatever that may mean. It's just a way of styling. And then some other HTML tags that are attached to it. So in the basis, everything is HTML. You just don't see it as an R user. You call functions that look like R functions, and we like that. Now, if you want to let your users interact with your application, we need some input controls. In the end, the goal of a Shiny app is always to let people do something with the data. We're not necessarily interested in creating static web pages that just don't do anything. So we're interested in input controls. We have a lot of basic input controls to choose from when it comes to Shiny, and they all have the same main ingredients, namely an input ID, a certain value, and a certain label. For example, in Shiny, we have an input control that is called numeric input. And as the name suggests, it is for giving a numeric input, so numbers. In this case, we provide an input ID, which in this case is number, but it could be anything, as long as it is unique. And that's important to note. We'll come back to that. Then we give it a label that's kind of put on top of the input so that people see what they actually need to do there. In this case, enter a number. And we give it an initial value. So when you open a web page, you will normally see that all the input controls have a certain value already. And this is what you basically provide when you put the input control into your Shiny application in the UI section. Other input controls are, for example, a button, an action button, which is a button that people can click upon. This one is a bit special because that doesn't have a value. Under the hood, it does have a value, but I'm not going to get into that. But what we provide here for an action button is simply an ID again, which is unique with a label that is being displayed on top of the button. Now, when your application runs, every user sees the same HTML from the UI. So the initial HTML that you put in the UI part of your app.r file. When the user interacts with the UI, you want the HTML to react to the user. So let's say that I'm a user and I selected a certain country from a picker. Then I would want the data to be displayed for that specific country as well. As a user, we expect that if we play around with input controls, that the HTML updates as well. Now, in order to make that happen, we need the server part of our Shiny app. And the server part of the Shiny app uses reactive programming, which basically means as much that whenever something happens in the UI, we make sure that the HTML gets updated correspondingly. Meaning that if we have outputs in our app, that they respond to the inputs. So the thing the output is dependent upon. And outputs can respond to this input because they are reactive. We call them reactive outputs. Now, Shiny has several functions to turn our objects into reactive outputs for the UI, and we call them the output family. Now, I have here a little table that just displays 4 of them, but there are many more. And besides that, you can use Shiny in combination with other Shiny type packages, like let's say eCharts for R, for charting. And you have different ones as well, but these are 4 example output functions. For example, we have a text output function, and the output type of that function is text, table output table, plot output plot, and UI output is a special one that provides raw HTML. This output family is important. These output functions is what we put in the UI to kind of tell our application, hey, here at this specific spot, I want to have a reactive output. Now, every output element that you put into the UI needs to have an ID as well, and we call that the output ID. It's a simple string that needs to be unique. And unique is going to be the keyword throughout this whole workshop, because all the IDs that we put into our Shiny application need to be unique. Otherwise, it doesn't work and Shiny gets a bit confused. Now, this text output text output, as I said, we put in the UI of our Shiny app as kind of a placeholder of a reactive output is coming on this particular place. So it tells Shiny where to display the object. Now the next step, obviously, would be to tell Shiny how to build that particular object. So how to build that particular output. And that's when we get to the server part of the application. And the server part builds the output, and it contains an object or has access to an object which is called output. And this output is a list. So just like regular R, you could print out output and you can see all the outputs that are registered in your application. Now let's say that in the UI, we just put an output with, which was our text output, that we put in the UI with the ID text. Then we can access it in the server by specifying output text. So here you see the ID matching. So each R object that you want to display in the UI of your Shiny application has its own entry in the output list. Now, each entry in the output list should contain a render function. So as you can just saw in the UI part of a Shiny application, we put functions like, let's say, text output. And then in the server, we want to tell it what that text output needs to be. So then we would say output text, and we would use the render text function. This will make much more sense when we actually get to an example in a little bit. But the important thing to remember is that if we are putting reactive outputs in our Shiny application, that it always has a function from the output family combined with a function from the render family, and these functions belong together. So let's take a look at an example. Let's say that we have in the UI this text output that we saw previously, and it has the output ID text. Now, if you want to give a value to that particular text, or we want to display text in that particular place, we would use in the server part output text and then use the render text function. And then within this render text block, we can put a simple string. We could say hello world, for example. And this principle also works the same with inputs. So we just saw that this output object is some kind of a list, and it contains all the things that we put in the UI. For inputs, it kind of works the same. We namely have access to an object that is called input, and that will contain all the values of the input objects that you specified in the UI. So just like the output object, the input object is list-like, and each input value has an own entry in the list. So let's take a look at a little bit bigger example, and we're going to run this in a bit as well in our studio. So here we have our UI, and besides the text output, we now also added a numeric input. We gave this numeric input an ID, namely number, with a label and value, and the text output has the text ID. Then in the server function, what we could do, we could say, hey, we want this output with ID text to be, in this case, the string, because we convert the number to string. We want to have displayed our particular number that we just provided, or the user provided in the numeric input. And we want to take the square of that. And then we display that in the UI. So this super simple Shiny application display or demonstrates how it works with connecting inputs and outputs. And I'm just going to head over to our studio right now, and then we can see that in action. Note that whenever there's a template available for one of these examples that I have, here it's displayed in the footer. So here we have a 00 base template that you can find in the template folder. Going to head over to our studio right now. Going to close this because that's for later. And then we will have a templates folder here in the repo. And here are all the templates, and we're starting with the most simple one, namely 00 base. This is our simple Shiny application. So let's see how that actually works when we run it. If we run this app, we make this a little bit smaller because otherwise it's on top of the screen. If we, yes, I will increase the font size in our studio. Thank you. If we would change this number here, we'll also make this a little bit bigger. If we change this number here now, so this is our input, and let's say we change it to 4, then we would expect the output to be updated as well. Now, you could already see here what happens when we remove this number. Then there's no input available, and it's also, of course, not possible to calculate the outcome that we want to have there. So whenever number I put in there now, whether it's 5, 6, or a very big number, the output will update correspondingly because it is a reactive output. Okay, now I need to find back my presentation. Note, I had a lot of issues with technical side here on this platform, and this is not my laptop. I'm not using my laptop that I normally have, so I'm honestly already a bit lost, like where everything is, and I just can't find wherever the slides are, which is very annoying. So I will just go to my own GitHub repo and put it from there because, oh, guys. Life can be tough sometimes. Okay, let me put up where we actually were, which was here with connecting the dots. Okay, I'm not going to make it super big because then I lose it. Right, bear with me. Great. We were not here, we were here with the inputs. All right, so we have just seen this super simple Shiny application that now displays the square of a number. Right, as you could already see in the application, whenever we changed the input, we saw that the output updated immediately. We didn't have to tell Shiny to do that. No, it just happened kind of magically. That is because an output is eager. It will update as soon as the input changes as well. And this eagerness is, of course, super handy because you, as the developer, don't have to worry about the output and if it updates correctly whenever the input changes. It happens automatically and you don't have to tell Shiny that. But sometimes this eagerness can become a little bit annoying. For example, as you could see already in our little demo application, if we didn't provide a number, then the output displayed NA. And NA doesn't look really nice, right? So sometimes we want to trigger a calculation only when we want it to. And the way we can do that is by using, for example, an action button. So an action button is an input as well. And what we could do here in the UI, we can add a particular action button with an ID. And then in the output, we can, behind the output, attach bind event to it. And with a bind event, we actually tell this reactive output, hey, you should respond to inputs, but only to the ones that I give you here. So in this case, we're saying, hey, output text, you can only update whenever input button is being clicked. So let's see that in action as well. Heading back over to our studio, and I'm going to increase the font size because because I promised that. Oh, this is very big. I hope this is big enough. And then we're going to the second template that actually contains this super complicated app with now this bind event. Now, if you already have seen Shiny before, you might also remember another type of function, namely observe event. I'll come back to that a little bit later, but basically bind event is a new way to bind events to reactive outputs or observers. So this is relatively new syntax. If you would look, for example, on Stack Overflow examples, you won't see this solution as often. That's just because this is new, but this is nowadays the preferred method, so I'm going to learn you that as well. Right, and I'm also using the new pipe operator here, if you were not familiar with that already. Right, if we run this application, then we now have this button that says calculate. And when I change the input right now, so to 6 or 7, whatever, we don't see the output firing. No, the output only displays the number if we hit this button calculate, so right now. And if I change it again, nothing happens with the output until I hit the button calculate. So this is kind of how you can stop this eagerness from your Shiny application, which is definitely handy sometimes. I'm also seeing a question in the chat very quickly, but I think that was already answered by David. The difference between the pipe operators is nothing, only that the native pipe is part of base R, and the one with the percentage thingies is part of Magitter. It's another package, and this saves one dependency. Okay, so that is bind event. Okay, back to observers, or back to observers. Let's start with observers. Now, so far, we have used these render functions to take care of the output. We used render text in this particular example. It's all happening inside the app. So within the Shiny app, we tell, hey, I have a placeholder here. I want you to update the HTML so that it displays something. So that was what I mean with inside the app. But in some other cases, we want to reach outside the application. For example, we might want to call an API when a particular button is clicked, or we might want to add some entries to the database. We might even want to print some stuff on the console, write CSVs, send debugging messages. We might want to do things that cause side effects, as we call them. Side effects that are really going beyond what the user sees on the screen and kind of do some internal back-end stuff. Now, in order to have side effects, we need something that is called observers. And observers are basically functions that run when their dependencies change, just as the reactive outputs that we have seen. But the outputs, as I said, they update kind of the content in the placeholder. They update the HTML in the user's browser. So that's kind of a special side effect. But observers are called for the other side effects that I already mentioned. For example, printing messages on the console. So let's say debugging. Here we have an example of an observe statement. And what this thing does, it is reaching outside of the app and it wants to display a print message or a debugging message on your R console. So we're going to print out whatever the value of the squared input number is, with a simple wrapping it within observe. Now, what we could also do here, and that is coming back to this bind event and observe event thingy, observers, just as outputs, are eager. They will trigger whenever what's in them changes, and sometimes you might not want that. As we already saw, we don't want to trigger the calculation if we didn't give a number, or if we gave a weird number, or perhaps we had a weird user that gave, I don't know, an A or a B or something that wasn't supposed to be in there, which you, by the way, can't do in a numeric input, but that aside. Sometimes we only want to trigger whenever an event happens. So also for an observer, similar as to we did with the output, we can say that we want to bind an event to it. Now, this syntax that you're seeing here, observe followed by this pipe operator and then bind event is exactly the same as saying observe event with then specifying the event that needs to be triggered upon and then the expression. Completely the same, just new and more modern syntax. Bind event, I have some other advantages as well, but I can't go too much into that right now. This is basically just what I want you to stick with from now on. Okay, great. We're going to make it a little bit more complicated by talking about reactives, but I first want to check with you all if this so far makes sense. Am I going too fast? Am I going too slow? Please just give me, I don't know, a very brief sentence in the chat or something that I can get a little bit of sense of doing okay. I see a thumbs up, so thank you for that. That's cool, more thumbs up. So a bit fast. Okay, I'll try to go a bit slower. I can imagine, because I'm not going to lie, the content that I have in this workshop is quite full on. But I hope you can bear with me and just ask any questions that you have, or also if you want me to repeat something, just tell me and I will do that. Okay, so we talked about two main things of the Shiny system already. We talked about outputs, we talked about observers. One big thing that we are missing is something that is called reactives. Outputs and observers, they do something. As I said, they do something because they cause side effects, namely sending messages, calling APIs, or they can have a special side effect, namely updating the HTML, so that a nice output or a number displays. But a reactive is different, because a reactive doesn't do something, a reactive creates something. And I'm going to use an example for that to make it all a bit clear. Reactive you can see as a function that returns a value. And you can assign reactives to an object, and you can refer to reactives elsewhere in your app. Now, this all sounds a bit complicated and technical, so we're just going to view reactives as a little backpack. That makes it easier. We can all imagine a backpack. A backpack can carry a value around, and whenever you want to have access to the content of the backpack, you just open it. So you can get to it whenever you want. Let's say that you go hiking. Now, you pick a backpack, obviously, that fits your needs. Are you going on a long hike? Then you're choosing a very big backpack that can have a tent or something. If you're going on a shorter hike, you're choosing a backpack that only holds a couple of water bottles. There are different types of backpacks that are fit to carry different things. And it's the same with reactives. We have a couple of different types of reactives, and they can carry different things. In this case, Shiny-related things and not hiking-related things. We have three functions for reactives: reactive, reactive val, and reactive values. The first one, reactive, is also the most, well, let's say complete one. It's the most biggest backpack you can have. It takes an expression, which means it can take a lot of things. Reactive val, as the name suggests, it takes a single value, and reactive values can take a list of values. So as I said, this reactive is kind of the biggest backpack that you have in the family. You can see it as a very fancy backpack. It can take an expression, meaning that it can take multiple inputs. It can manipulate those inputs. It can return something simple like a single value, but it can also return complex things. And it can even take other reactives, other backpacks, so to say, as input. Let's take a look at an example for that to make it all a bit more clear. So we're sticking with our numbers app. And in this number app, I created a reactive. This reactive we assign to a value, and it is called number squared. This number squared and this reactive it holds an expression. In this case, this expression is not very fancy. Yeah? We're still, having a simple application. This reactive holds an expression that calculates the square of a number. So this is the code that we've seen before. Then this number squared, we can also bind an event to that, similar as what we did with the output, what we did with the observe, so that it only triggers to this particular event. But once that event is triggered, we have this object now, number squared. And this number squared, we can call in multiple places. You could also say it's a backpack that kind of replicates itself, but let's just see it as a backpack that goes from one place to the other. For example, we put this backpack in line 20, where our output is at. But we also put this backpack in line 24, where our debugging statement is, so our print statement. And this is cool about backpacks, you can pick them up and you can have them in multiple places, open their contents and move on. As you can see here, previously we needed to write input number with the roof thingy and then 2. We needed to write that 2 times. Now we only have to write it 1 time. It's kind of a special function, so to say. Sorry, I'm going to drink some water in between. All right, so we have this special reactive. Now, the difference between a reactive and an observer and an output is that observers and outputs were eager. They triggered as fast as they could, and they went for it. These reactives are different because they are lazy, and this means that they are only opened when you ask for it. And if we want to talk a little bit more technical, then it means that when the dependencies of a reactive change, it doesn't re-execute right away, but it waits until it gets called by somebody else. So this is very tricky perhaps to visualize in the beginning if you're new to Shiny, but you could see it as a reactive only fires whenever another function calls it, and an observer and an output, they trigger anyway, whether or not you needed it. So you can already imagine that in some cases, reactives might be favored instead of outputs or observers in this case, because of this special property that they have. So we saw the reactive that would take an expression. We also have the reactive values, and these are simpler backpacks because they take, simpler values. One takes a single value and the other one takes multiple values. You can make a reactive value by calling the reactive val function, and you can update it by calling it with a new value, and we will see that in a bit because this sounds all a bit cryptic. Then reactive values, you create them with the reactive values function, and you can update them by assigning a new value to them. So let's take a look at that. Here we have the same code, but now rewritten with reactive val. There's also a slightly difference here because you need to initialize reactive values. So at the beginning of our server part, line 15, we say, hey, I have this number squared, but it starts off with the number 0. That's what I'm saying here with reactive val 0. Then what we can do there in line 18, that whenever the button is being clicked, we update this number squared with whatever number the user gave and then square it. So this number squared in this case looks like a function now, where we give an argument, which is just the value that we want to update it with. And then in line 22 and 26, we can call it again, very similar to a reactive and how that looked like. So here again, no need to reuse code. We can just assign a value somewhere once, and we can call it in other places. Reactive values looks a bit different because reactive values is a different kind of object. It's namely a list-like object. The list-like object can take multiple named values. So for example, here we initialize a reactive values object that we call R, or a petite r, but I'll come back to that later. And it will have a value called number squared, which we initialize with 0. Then in line 18, we assign a value that we want to give this number squared property. We assign it there. So this is different than what we saw from reactive val. I'm quickly going back. You could see the difference here with updating is that you provided a new value within the function, or number squared lookalike function. And here we assign it in another way. And then again, we can call it in multiple places, like in line 22 and 26. Right. So what we can also see is that the reactive values, it's some kind of reactive mini database, you could see it, because it can have multiple values, can have multiple, as many values as you want, and you can update them in different places, you can retrieve their values in different places. So it's a very convenient object to be passing around in your application. And we're definitely going to come back to this reactive values object and this petite r that we just saw when we're going to talk about modules and sharing data between modules. And now time for a breather, because I don't know what you all think, but that's quite a lot, to grasp at the beginning if you're new to Shiny. This is like the quickest overview that you can have on all the base concepts of a Shiny application. So if you feel overwhelmed at this stage, don't worry, because in the next hands-on part, we are going to go line by line through an application yourself, and then it will all make much more sense. Okay, when I first started with Shiny, 6 to 8 years ago, the hardest part really for me was that a Shiny application doesn't run line by line. If you're an R programmer, you're used to have an R script and just, go from one line to the other line, etc., etc. And you can run it, see the results in your environment, you can inspect the objects, and it all kind of makes sense. You can wrap your head around that. But with the Shiny app, and especially the server part, it's more difficult because code there doesn't run line by line, because the server is built on the principle of reactive programming. Chunks of code run whenever their dependencies change. That means that some code in line 350 of your script can run before something that is in line, let's say, 100. And in the beginning, this can be very hard to wrap your head around and to test your code, because you can't print it out on the console. So I'm going to give you 2 tips for that, and probably some of the things that we'll be using as well when we're getting to coding. But first of all, we can put print statements in here. And that's what we already saw with the debugging print statements that we saw earlier. So if we want to have information about what an input looks like at a specific point in time or in a specific observer, we can simply print it out. And then we see it on the console, and it will make much more sense to us. This is the most simple form of debugging your Shiny application, put print statements everywhere. However, there's also a bit more advanced and clever way to do that, and that is with the browser statement. You might already know the browser statement from debugging functions and such, but the browser literally stops execution of the code, and it allows you to inspect what the environment looks like at that point in time. This means that you can literally inspect what the input object looks like, what its value is at that point in time, what the reactive values look like, and what their value at that moment is. And this makes debugging your Shiny application so much easier. So remember that one. You can put it in anywhere, in outputs. You can put it in observers. You can put it in reactives. So it's super convenient. A quick part about the looks of a Shiny application. We developed so far this very simple number application, which absolutely looked, well, boring, quite boring. And we want to build fancy, shiny applications. So I'm going to give you some quick tips to make that happen, and we're going to see that in action once we start developing our real app. We can make our app look better by simply implementing some add-on packages to Shiny. One of them, which I briefly mentioned at the beginning of this workshop, was BSLib. And BSLib makes it possible to upgrade, for example, your Bootstrap version from version 3 to, let's say, version 4 or version 5, which also comes with a bit more modern look and feel. I think I saw that question in the chat at the beginning as well. How is it with Bootstrap, and can we use another version of Bootstrap? Yes, you can with the BSLib package. And a quick crash course on BSLib, how that looks like in the app that we've built so far with the numbers. We have here a simple UI still, but what we did now is we replaced the fluid page with something with a function called page navbar from the BSLib package. And in that page navbar, we have the option to set a particular theme. And in this theme, we can change the Bootstrap version if we want. So in line 5, I changed the Bootstrap version to version 5, and then Shiny seamlessly upgrades the version of Bootstrap for you. You can also customize this theme even more with all kinds of colors and a font and all kinds of fancy stuff, which we will do later on as well. Okay, I'm quickly going to show you what this app looks like, because now we're all curious, of course, and this is the BSLib template. This BSLib template, we will work from in our app in the hands-on part, which will follow shortly after this. So we have here our custom theme where we can specify all kinds of things if we want to, but I'm going to keep it simple with a preset. A preset is basically a boot swatch theme. You can check out this website if you want to for all the themes that are available. And this preset, there we can choose, I think there are 12 or something of them, which completely change the look and feel of your application without doing any effort. So we're going to make it ourselves a little bit easy here and just choose a preset. And we can choose a font, and you can go as far as you want. And then here we have this page navbar where we say that we want to use BSLib as our main UI. If we run this application, it looks like this. And guys, come on, with a couple of lines, this boring app that we had looks much more interesting. Well, I know for a fact that David absolutely hated this bluish and pink, but I'm just going to ignore him because I do like it. So we're going to stick with this for the rest of the workshop. But if you want to change that, it's also, a matter of simply changing one line of code, and it looks completely different. But that's how easy it is to level up your Shiny application with just a few lines. Okay, great. Right. So this was kind of the introduction on Shiny before we get started with the hands-on part. If you, by the way, get an error about the nav panel and such, make sure you have the latest version of BSLib. BSLib is still heavily under development. It kind of gets updated, I don't know, every 2 weeks or something, 2-3 weeks. So make sure that you have an up-to-date version. Okay. So we now covered the UI part, the server part, how to connect the two. We talked about observers, reactive values, events, a lot. And now it's time to use some real world data and really start building our first Shiny application. So we're going to head over to R, and I encourage you to follow along with this. I'll literally go line by line. I'm a fast typer. I'm not going to lie, I can type very fast, but you can follow along as well. And I'm basically going to start from this template, so the BSLib 2. And then I'm getting all my stuff here in order so that I know actually what I am doing. But I'm going to, first of all, create a new folder here. And I'm going to call it ShiScores. I gave it that name because I didn't actually tell you yet, but we'll be using international women's football data, or soccer, depending on where you're coming from. The one on the green field with the ball and stuff. We call this football here in the Netherlands, but for Americans, I think it's soccer. So sorry if I offended anybody. But it's women's international soccer. Let's call it that. And I'm calling this app ShiScores because I think that's a brilliant name. So I'm going to create a folder for that. And obviously later on, I'm going to push the code to GitHub as well so that you can see the finalized result there. Okay, we now have the ShiScores folder. And within that, I'm going to start with my app.r script. So that will be our basis. Now, as I said, what we will be doing is we'll start with this 02 bslib template. So I'm just going to grab that in full, going to copy that, and just going to paste that in right there. And then I'm going to make some changes, because obviously this is about numbers and I want it to be about soccer. First of all, I'm going to remove all of this because this was just for demonstration purposes of what kind of arguments you can put in there, but we won't need everything. It makes the code much shorter. We're going to change the title of our application, and we're going to call it, well, I don't know, something like Women's International Soccer Data. Women's. And normally I would have a little football there emoji, but this Mac doesn't have my pretty touch bar, so I'm not sure where to get the football. But we can put a title in here. We are going to replace this entire content by something else in a bit. And we're going to change the title here to, let's say, competitions. Or what should we call it? What I eventually want in this main page I want to display some value boxes and a graph that kind of tells us about the number of matches that have been played over time. The data that we'll be using is an historical data set for multiple years. So it would be nice to display year on year how many matches there were played. And in the value boxes, I would want to show something like who's the best scorer, who made the most goals, what is the best country, etc. So I'm going to call that overview because that is what it is. And our app is obviously called ShiScores. So we're going to use that. Okay, so then we have our nav panel title. This I don't need in the server, so I'm completely going to remove that. And what we didn't talk about yet is how are we going to make sure that data ends up in our Shiny application? Because in our case, we have some data in the data folder. So here on the top level folder data, we have some RDS files, soccer scorers, soccer matches, the country rank, which we can use in this application to be read in. Now, as you know, there are two parts of a Shiny application, the server part, the UI part. But what is this part? We didn't actually give it a name, but normally how you would call this is the global part. Whatever you put in here, in this global part, you can access in both the UI and the server. So we already see that here with the custom theme. This custom theme we define, let's say in the global part, and we call it in the UI, but we could just as well have called it here, and it would have worked perfectly fine. So this is really the correct place to put the data. And we're going to read that in as an RDS. So let's do that below the theme. And what we're going to do there is we're going to say, I have soccer scorers data. Scorers, difficult word. It's not even right. Scorers. And I'm going to read that RDS in. And I'm going to read that in from the data folder. Now, because this is a demonstration and I put the data top level, we need to go one level up from the working directory as well. When you run a Shiny application, the working directory is set to wherever your app.r file lives. Now, in that working directory that I just created, namely ShiScores, there's no data folder there. So we need to go one level up, and we're going to do that by the 2 dots. This is just our stuff. But normally you would put the data, inside the working directory itself, and then just use 1 dot and not 2. So we are going to read that in soccer scores. And we're going to do the same for the other 2 data sets that we have. Probably we will not use all of them, but we can as well have them here, which is the matches data. And we will have the rank data. Soccer rank. Okay, that is great. Now, as I said, I want to have some value boxes in there. So we're going to make that happen. And we're going to include them here in this nav panel that we just called overview. Now, what I didn't tell you yet is that Shiny works with something called a grid system. And that's actually coming from Bootstrap. It means that Shiny works with rows and columns. And it means that we can attach rows to our page and we can divide them into columns. I just read a message about me making a typo, country rank. Is it true? Oh, yeah, you're completely right. Soccer rank, country rank. That's what happens if you're talking and coding at the same time. Then it will not go right. Yeah, I'll rename it to soccer rank anyway, but I do need to use the country rank data. Thank you for that. Okay, so talking about this rows and columns system. So let's say if I want to have a row that displays 3 value boxes next to each other, then I would say that I want to have a row, which is called a fluid row. And in that row, I want to have 3 columns. So I basically want to have something like column, and I want to have another column, and I want to have yet another column. I want to have 3 of them. Now, the special thing about the grid system is that you just need to remember that columns are always 12 and 12 length. Which means that if we are going to divide a fluid row into 3 sections, is that every column has a width of 4. So 4, 4, and 4. And it always needs to end up in 12. Now, you can already imagine that in some cases, if you want to have 5 value boxes next to each other, that's going to be a little bit of a problem because that doesn't go well with the number 12. There are ways to come around that with CSS and stuff, but that's too much for now. So we're just going to focus on the 12 and that every column has a width of 4. Okay, so then within each column, I can start creating value boxes. Value box is a function from BSLib as well. And what this does is it displays a nice box where we can give a title and let's say a particular value. So for the first value box, I want to have, let's say, the top scoring country. So I can give this value box a title, namely top scoring country, and I can give it a value. Now, this value, I would very much like to have the name of the country, and I would like to have the country flag. Let's first inspect the data. And if I'm going to do this now, it's going to error because it can't open it. And that's because the difference between Shiny and running it locally is the 1 dot and the 2 dots. But I'm just going to put them here in my environment, and I'm not going to do that super efficient, but you get what I want, so that we can see what the data is actually about. So I have the top scoring country, and I'm going to find that in this soccer rank, which is actually coming from the country rank data, but I renamed that to soccer rank. If we click on this data, this is what it looks like. I already did some data preparation for this particular data. You can also find it in the data folder, which is a script I call data. I believe it's called data preparation, where I do all this kind of stuff, like including country flags and such. And here I already ordered what kind of the top scoring country is. It is the United States in this case, with a lot of goals, followed by Germany and China. And I added a little flag to it wherever I could find a flag with the function that is in that particular data preparation script. But I want to add that in the value box. So I'm going to use this country and this country flag. So I'm going to my app. And for value, I'm going to say that I want to have these two pasted together with a normal paste. And because this data frame is already ordered with the top scorer on top, I can simply call head. So I want to call this rank, and then the country, and then the first one. And I want to paste the head of I want to paste the flag to that, so the country flag. I'm also going to take the first of that one. So that's then our first value box that we're going to put in there. Then our second value box, I would like to have the top scorer in there. So I'm going to give, I'm actually going to copy just this whole value box, because we're going to kind of do the same thing, but now we want to have the top scorer and not the top country. And we're going to call this the top scorer without country. And instead of using soccer rank here, we're going to use soccer scores here. So I will have not the country, but the scorer. So let's take a look at that soccer scores data, by the way, because I know what it looks like, but maybe you didn't check it. This is the soccer scores, what the data looks like, with the name of the scorer, the team that she belongs to, the goals, penalties, and the country flag again. So super simple. This is not going to be the most interesting app data-wise, because that's not the point of this workshop. But after this workshop, you're completely free to do with the data whatever you want and make it even more interesting. So that is our second value box, which is for the top scorer. And for the last value box, I simply want to display something relatively simple, which is the total countries that are in my data set. So I'm going to copy the value box here as well. And instead of top score, I'm going to say total countries. And what I'm going to do here is I'm not going to use this paste, story, and country flag thingies. I just want to display a number, namely the length of the unique soccer matches home team. There's a home team and an away team in this particular data set. So this is the soccer matches data set. It contains the date of all the matches that have been played, the home teams, the away teams, what their score was, which tournament it was in, the city, blah, blah, blah. A lot of data here to play around with. But I'm interested in the number of unique countries that are in there. Okay. So now we have 3 value boxes, and I'm sure we all kind of curious at this stage what it is actually looking like and if it is all working. Don't freak out if you get an error in Shiny or whatsoever. That's completely normal. It still happens to me every day. It might happen here during this workshop a couple of times as well. Stay calm and inspect the error message and you will be fine. So let's run the application, and this is what it looks like. These giant, absolutely giant value boxes. Make it a bit smaller. But we now have the 3 value boxes with the data as we expected, the top scoring country, top scorer, and the total number of countries. Okay, great. I'm quickly going to check the time because I want to discuss a lot with you, and I don't know if I have all the time to do that. What I would want to see here as well is a graph. And it would be nice to display, let's say, the number of matches over time to see how women's soccer has grown over the years. Because especially in more recent years, there have been a lot of matches and more attention for the sport. So you will also see that nicely in a visual. I unfortunately don't have the time to code that completely with you. So instead, I'm going to put that in the code later on. We don't necessarily need that graph to, to explain any of the Shiny concepts. But I'm going to make sure that after the break, I will see or show you what it is actually looking like. So far, perhaps this is going a bit quick. As I said, all the code will be available later on as well, so that you can look at it at your own pace as well. For now, we'll leave it here for this particular hands-on function before we're going to move on to the modules part. And I would propose now to kind of take a quick break for 10 minutes so that you can grab your coffee or whatever you want and kind of get a breather. And then after that, we continue with the modules and stuff. First of all, a quick question. Everything still going all right? Can you follow it? Do you feel ready for the next section, or do you think, "Ooh, this is kind of a lot"? Just give me some indication if you're still enjoying it, and I'm so happy to see a lot of thumbs up. That's looking very good. Okay, I'm going to set a very fancy timer for 10 minutes. Cookies. This is also giant because I set this to massive size. Cannot even. Ooh, started. Does this work? Oh yeah, okay. It already started. Good. I'm going to turn off my my camera and mic. I will see you back when this timer ends, and then we will continue with the module part. So see you in a bit. that was quite a dramatic ending of the timer. I didn't know it would end like that, but I hope everybody is awake again. Okay, so this timer can go. I'll put my our studio back on the screen. Okay, so what I did in the meantime is I pushed something to GitHub again, and I put it into the instructors folder. I will put it here as well. This is another device. I put it here in the instructor folder, and it's called 01 app. And this is basically the starting point that we're going to depart from right now. So you can get started with that file. This file will contain this particular app that I have here, and it will look like this. Like this. And I'm going to the code in a brief moment, but I just want to show you the results first. So this application actually contains the particular app, particular graph, sorry, that I wanted to implement, and I'm using eCharts for R here in this case, because I really like that package and the look and feel of the application. And we will see the code in a bit. And what else is different here is that we finally have my emoji that I couldn't find on this device. Woohoo, winner. And we have an additional thingy here in the navbar, which is called countries. And this countries contains a page setup. And if we click on that, we there have a picker input. This picker input is from the Shiny widgets library. And this picker input contains basically all the countries that are available in the data with their country flag after it. And we can select one or multiple. I'm briefly going to go over the code. And I really would have loved to do this with you line by line, but unfortunately, due to time, I can't do that. And I really want to cover modules as well. So just if you tuned in just now, if you pull again from GitHub or go to GitHub, and if you go to the instructor folder, there is a 01 app file. That is the new starting point that we will be going forward with. This is the content of that file. What it is looking like here is that I now, in the global section, I put two additional things, namely the available countries. This is basically an object that I'm creating to put into the picker. And it paces together, you know, the home teams and the country flag and all of that. I pushed the instructor folder to the main branch, so it should be there. It could be that it's not in your fork because you would need to update your fork. If you go directly to the URL of the GitHub page, you can also grab it from there and copy it and paste it to your own RStudio environment. What I did here then is I put in this little nav menu. So that nav menu in which we saw the countries with the setup page. This nav menu contained a nav panel with, you know, this setup page and this picker input that I mentioned. This picker input is coming from the Shiny widgets library. And I also added some other libraries here that we would need for the eCharts, namely Liberdate to work with dates and dplyr for some data manipulation. This picker input has all kinds of nice options to kind of enable searching in the picker and to select or deselect all things that I all very much like. So please check it out at your own after this workshop if you want to know more about that, with a simple action button attached to it. Then in the server part, we have added our eChart. And eCharts works very brilliantly together with the tidyverse. So what we simply do here, we pass in some data, do some summaries, and then we simply say to eCharts, hey, I want to now construct a chart with the date being on the x-axis. And then we want to have a line displaying the number of matches. And we can all give different styling options like colors for axis and colors for the line, etc. It's a really cool package. So again, I encourage you to check that out. The other thing that I added here on top is the e-comment function. This is also part of eCharts for R, and this is to set the font family of our lovely chart so that the font family aligns with the rest of the app. So if we're going back to the application, we can now see that there's just, this nice font, which we all like. Okay, great. Then I'm going to go back to my slides. And of course, I lost them again. Oh, I have too many browsers here as well. Okay. And we're going to head over to the modules part. Reactives, looks, we got it after the break. Shiny modules. Okay, good. There's lots of talks about the flags. Well, just don't use Windows. No, that's not the solution for that problem. I sincerely just inserted the, you can check it out in the data preparation script, how I did that. It's in the data folder. It's with a simple function that looks up these country codes. What is the package called? I don't know from the top of my head, but it's looking up the country codes, and on Apple, at least, you can translate it then to an emoji, and I literally, in the script, paste, the emojis. So it could be different on Windows, definitely, but I'm sure there are solutions for that, or just omit the flag. The picker is part of the Shiny widgets package. It's not from Shiny itself. I think Selectize input is from Shiny itself and not Shiny widgets. So that's why you might see a difference. Okay, to Shiny modules. Modules, what are they? People find them really scary somehow. If you talk about modules, then people are like, as an advanced subject, or not ready for it, or it's only, you're very far along in your Shiny journey. But I hope to demonstrate you during this second part of this workshop that it is not the case, and that you can start with modules immediately. Because basically, modules are just special functions, and you use functions in R all the time. So why not in a Shiny application? And in fact, you're already using a lot of functions in your Shiny app. We're using functions in our UI, like, for example, value box from BSLib. We're using functions in our server, like eCharts, and all kinds of things. And this works well, but it works well because the code is completely either on the UI side or on the server side. And if we have code that is partly on the UI side and partly on the server side, then normal functions won't entirely work, but modules will. And modules consist basically of some UI code that works together with some server code. And modules are very special because you can see them as an own little mini app. And this mini app has its own namespace. That means that the IDs that we previously given to our inputs and to our outputs, I said constantly that they needed to be unique. And you can already imagine that if you have a very big application with lots of pages and lots of functionality, if you have multiple number inputs and you all call them number, then at some stage you have a clash, and you can't remember what kind of IDs you used everywhere. So that becomes very annoying. If you make use of modules, you will eliminate that problem, and you will actually work in these kind of isolated mini apps within your bigger app that make sure that you don't have namespace clashes. We will see that in action a little bit later. Now, this namespace thing is one of the two main reasons why you should work with modules, because you don't need to worry what happens in the rest of your applications. And besides that, a module is a function, so it has all the benefits that functions have as well. You can pick up functions and reuse them somewhere else. You can pick up modules and reuse them in other applications. You can use modules multiple times in the same applications. You only have to write modules once, and then you can simply package them up and pick them up and use them wherever you want. And that is a big advantage. Now, what does a module look like? A module has two parts, and as I said, it's basically a little mini application. Just like the app.r file, it has a UI part and it has a server part. So let's take a look at a module, and we're going back to our very simple base example with the squared number. Now imagine that we want to put our code that we previously had in the UI, but we want to put it into a module instead. So we're going to define a module here with the name number module UI, very original, line number 3 that is defined. And we're basically going to put everything that we previously had in the UI, we're going to copy it and drop it into this module function. Now, that's not all, because there are a couple of special things here that you might already notice. For example, line number 4 defines the namespace. That is what NS stands for, namespace. And technically speaking, you would wrap your IDs, your input IDs, into a namespace by using capital letters NS, then the name of the input you want to namespace between these quotes, followed by ID. Now, if you need to write that every single time, it's kind of getting annoying. So there is this little trick that you can do by assigning it to NS with lowercase. And then you can use this NS to wrap your input IDs in. So in line number 6, 9, and 11, we see that both our input IDs and our output IDs are wrapped in this special magic NS, this special namespace. If you encounter any problems with a module at any time, 9 out of 10 times it has to do with you not wrapping an ID in NS. That's literally the most important thing you need to remember about modules. It needs this to work. You need to tell, hey, this is my little mini app. This mini app has its own little namespace. So all the IDs that are supposed to be unique, you need to wrap them into NS to tell Shiny this is belonging together in its own little cozy namespace. And what we also do here is we wrap in line number 5. I didn't highlight that, but in line number 5, we actually putting all these inputs, like the numeric input, the button, and the text output, we're wrapping that in a tag list. And a tag list is nothing more than just a way to bundle HTML and ship it. This is also a module-specific thing, because a module needs to return something in the end to the main app again, and therefore we need to wrap it like this in this tag list. So that is the UI part of a module. Important thing to remember, this NS function and wrapping all your IDs in it, put it in the tag list, and it's basically the same as what we previously did. Then heading over to the module server, also kind of looks the same, because line 17 to 19 is exactly what we put previously in the server part of our application. Only now there is some extra stuff around it, which has to do with the module. First of all, the name of our module server, which is in line 15. And what we do there is we simply append the module server to an object so that we can call it elsewhere later, just as what you would do with a regular function. And then On line 16, we have this special function that is always there, module server, which takes the ID, and then again, the input-output session that you also saw at the server part of the normal app.r application that we started with. I think RStudio also has some snippets for modules, so you actually don't have to think about this at all. You simply need to give it a name, and it will automatically inject the module UI and the module server in your script. So then you don't have to remember this all from the top of your head. And then this is basically the mini app. So this is your module UI, your module server. Now you can pick these modules up. Together they form one module, by the way. So you can pick this module and the module parts up and put them in the main app. And that is simply the same as that you would do with regular function calls. So let's take a look at that. Our main app was the UI and the server. So now in our UI, instead of specifying all the inputs there directly, we say, hey, we have this nice, cozy number module UI that we just made. And we're going to give it an ID. Now, this ID does need to be unique. It needs to be unique because it's called in the top level, we call that of the application. It's called in the, let's call it the main app. In the main app, everything needs to be unique. So in our UI, we're calling the number module UI with an ID. We call it numbers, and that matches with the module server that we insert in line 28, so in the server part of our application. This tells Shiny that line 24 and 28 belong together. This is kind of the mini app that we have in the bigger application. Okay, so what do you actually put your modules? Because you can imagine if you have a very big application that you have a lot of modules, where do you leave them? Well, the first option is to do it like we did in the script that you just saw, just on top of the app.r file. So kind of in this global section where we also did put our data and our package calls, our library calls, and all of that. But there are also other options as well. Namely, if you put a separate script with any name that you want in the R folder, Shiny will automatically source your modules. So that's super convenient. The other option is to put it in another folder, so not the R folder, but basically whatever you want to call your folder, and source it in your app.r file by using source and then calling to wherever your folder is and wherever your R script, which your modules is. So the second option is a bit more verbose, I would say. So either put it in the R folder, that's the easiest, or just put it on the top level of your app.r script. And we're going to continue with that very first option, just because I want you to simply work with one file for now before we start having scripts everywhere. Okay, so modules are composable. As I said, you can pick them up and you can put them everywhere you want, as many times as you want. This also means that you can call modules within other modules, and we call this nesting. Now, nesting modules sounds even more complicated than modules on their own, but it's basically the same as you would call a function in another function. And honestly, you also do that all the time in R scripts. You call the mean function in a function that you created probably. It's just how R works. So it's not any different for Shiny and nesting modules. So let's take a look at a more complicated example, which I'm also going to show you what the result of that looks like when we actually print it out. We have now, besides the module that we firstly created, we have a second module. I call that module 2. And in that module 2, we're going to do a number analysis. What this is going to do, it's going to display a table with all the numbers that are kind of around the number the user has chosen. And this makes more sense if we actually see what it looks like. So before I'm going to explain the code, I'm going to head over to our studio again, and we're going to open that template app, which is called this one, nested modules. So if I'm going to run this application, what we will see here now is that besides our number, we also have a table with 10 numbers in this case. Now, if I update this to 6, then we just get the output as that we're used to, but the table kind of stays the same for now, but we will change that at a later stage. So going back to the code, going to close this. Going back to the code, we will have here the module that displays this simple table with the DT package. And we are giving this table the ID table, and not forget, put NS around it, put the namespace around it. We simply generate here, as you could see, with render data table, a table that takes numbers from 1 to 10 and then generates a data frame out of that. So it's a super static table, and at a later point, we would want to change that. But the point that I want to show you here, that is this second module, we could call that anywhere we want. We can nest it. So if we're going to look where we can put it, we had our initial first module, which was called number module UI and number module server. So this was module 1. In this number module UI, we can simply call another module, for example, our new number analysis module UI. And the server part, we can also simply call. Just remember that the IDs need to match. So in this case, both of the module parts have the analysis ID, and this is how they are linked together. But this module is called within another module, so it is now nested. Now, if we're looking at our main UI and our main server, then we see that we are only calling one module there, namely our first module, and not the second module, because that is called in the first module. Kind of gets like a module inferno, if you want to say it like that. But this is basically calling functions everywhere, and you can call them wherever you want. You can take this quite far. You can have modules and modules and modules and modules. It never stops, basically creating this module inferno if you want to. The nice thing is about modules is that you only have to write code once, and you can use it in as many places as you want, even in other apps, because they are kind of their standalone mini applications. They can be used everywhere. So if you constantly have a particular table with particular styling, etc., and with particular buttons and options and filters that you want to show in your Shiny application, make a module out of it, and you can reuse it in whatever app you want, which is very nice. Okay, so back to our ShiScores app. As you saw, we just added a countries nav menu, and within there we had this setup page. In the setup page, we could choose different countries. Now, it would be cool that every time a user selects a particular country, let's say Albania, that a page gets generated for that particular country. And if we select then another country, let's say United States, that a page for the United States gets created. Now, every country page or every team page can kind of look the same. Eventually, we want to have information about a particular country, about a particular team, like how many matches they played, what kind of matches they played, what the result was, etc., etc. So every page could look the same, but the data just needs to be different. And there are many countries actually in that whole data set. So we are not going to write, a module or some code for every country that a user could potentially choose. So this is a perfect use case for modules because we're just going to write the code once, make sure that it takes some data, and the data could be different in any case, and we are using these modules to be displayed dynamically so that the user can pick every country he or she likes, and the pages get displayed. Okay, so we can start calling modules dynamically. Then another question that will arise later on, and often one of the questions people ask most of the time, well, I've written a module, works all very nice, but I did something in a module right now, but I want to use whatever I did there in another part of my application. So basically, I want to share data between modules. And that is often seen as a hard part, but there are actually multiple strategies to be doing that. And one of the strategies we'll be using in the hands-on part of this, in the last hands-on part of this workshop, is using reactive values. Remember this petite r I talked about. And reactive values, as we saw in the first part of this workshop, could be seen as some kind of mini database. They can be used to store multiple values. Values can be updated. Values can be accessed. Super handy as, a vehicle to pass around in your application. And the convention is, or the convention of the strategy du petit r, is that you call this little database R, so the small r. And we're going to use this principle. So what does that look like very quickly for this number application? So in the server part, we initialize our mini database, our petite r, our reactive values object. We could have a number in there, for example, and whether or not the button was being clicked. What we could then do is we can pass this database along to our modules. Remember, modules are just functions. They can take arguments. And just as in a function where you would say what the arguments are, you do the same with modules. So we could simply allow our number module server, for example, to take an additional argument called r, and we're passing in our mini database to it. So then you would see in our number module server, r is r, or you could simply omit one of the r's if you are already sick and tired of seeing so many r's, and you can simply put one r in there. Then within this number module server that now takes this r object, we could manipulate it. We could update from within the module this particular value or the values in the database. So if we want to have the number updated, we can simply, whenever the input changes, simply assign a new value to our number. And we can do the same for the button. Now the button, I didn't mention that every time a button is clicked, it kind of gets +1. So it starts off, if you start up the application, as a 0. If you click it, it becomes 1. Do you click it another time, it becomes 2, etc. So we can store this value of the button as well in this mini database. Then in our second module, our number analysis server, we could also use this r object. So in line 49, we simply specify it as an argument of our number analysis server, and then we can call it in different places of this module. So line 53, 54, we're calling it in 57, 59, and 60 to kind of work with these values. And I'm just going to show you what that looks like very briefly. This is the sharing data template. So when we hit a number now note that in this particular code, I also put in the module 2, the bind event to the button, so that the table actually doesn't show if I didn't click the button yet. So if I enter a number here, let's say 4, and if I now hit calculate, then the table shows up and the number here that we're used to. And I also added some additional styling to this DT. Is just a border that shows underneath the number that was chosen. So if I pick 5, then you see now that the line changes underneath the number 5. You know, super exciting application, but just to demonstrate to you the point of sharing data between modules. Okay, time to head to the real deal, namely our ShiScores app. And we're going to call modules there dynamically. I am looking a bit at the clock as well. I'm not going as fast as I would have liked because there's a lot to tell. But I'm going to try my best to get everything in while still being, you know, making sense. So bear with me there. Okay, so we're going to start from that starting point that I said was in the instructor folder, so the one with the e-chart. And what we're going to do here is we're going to make sure that we can call modules dynamically. So what do I want to do? I want to insert things in the navbar whenever a country was selected and the button was being clicked. So I'm going to open this app once again to demonstrate what we're going to do. In the setup page, I have this picker with the country. Whenever I select Albania, for example, and I click Generate Pages, what I would want is that underneath Setup, Albania appears. And if I would do Algeria, Angola, Aruba, in this case, I select now Albania, Aruba. When I click on this, I want to have Albania and Aruba here. So that is the goal. Right, sounds complicated, but I promise you, once you see the solution, it all makes sense. The first thing that we need to do here is we need to make sure that when we want to update the navbar, it means that our navbar also needs to have a particular ID. Otherwise, we can never identify it. Currently, it doesn't have an ID. So we're going to give that. So here we have our page navbar with our title, and we're going to add an ID to it, which we're going to call navbar ID to be able to later update it. And what I'm now going to do here, so after this available countries, I'm going to create the modules. The module that will eventually make up our pages, our specific country pages, with the information that we want. So I'm going to create here a country page UI. And this country page UI is going to be a function with a particular ID. This is the basis of what a modular UI looks like, plus this NS hack, I call it, to make sure that you can write NS with lowercase, and a tag list, in which we are going to wrap all the output that we would like to see on the page. Then for the server part, we're also going to create that skeleton here. We're going to call that country page server. And that's also going to be, a function with an ID argument. And then underneath here, we have module server. You can get this from a snippet. I never remember this by heart, by the way, but I'm just going to type it here out for you. We have a module server here that also takes ID as an argument, and it takes another function, and that function is the same as the server function of an app, of a Shiny app, with input, output, and a session. And since this is a function, we here have these nice curly braces. So this is the skeleton of our country page UI and our country page server. In our UI, I want to have a header. Would be nice, you know, if the page displays what country we are looking at. going to come back to that. But I want to have an H2 here. I also want to have a card. And this is a BSLib card, which is just a nice outline around some content, which makes it look cool. And in that card, we can set a card header and we can set a card body. Now, this card header is going to be the header of the card, and I'm just calling this general info. And the card body is going to be made up out of, I just want to put a simple text in there. So a text output with an ID. Now, remember, number one thing, you can write that down. You can put it on Post-its or whatever when you're working with modules. Don't forget an S. So normally you would provide an ID here, like, I don't know, general info. But what you would do now, working with modules, you need to wrap it into this namespace. And that's the only thing that you need to remember. Besides that, I want to put here a table as well. So similar as what we did with the numbers. And in this table, I would want to display all the matches that have been played by that particular country. So I'm going to use DT output here. Again, wrapping this ID into a namespace, and I'm going to call this matches table. So that's our UI. Now here, I would like to display the name of the country that it is about. The name of the country I don't know at this stage, but what I could do is I could pass the name of the country as an argument to the country page UI. So besides ID here, we can also put an argument in here. Let's say page name. And then we could use this particular argument in the H2, like this. I'm also going to give this card a minimum height, by the way. You don't know that, but I do. Otherwise, it will be too small. So we now have our country page UI that is ready to be called whenever we want it to. Okay, in the country page server, we would obviously want to have the text that we would want to display, and we would want to have the table. So what I'm going to do first, or what we need to do first, is we need to make sure that the data that we're displaying in this particular country page is for this country alone. And to do that, we're going to create a reactive. Now, remember, reactive was the most fancy backpack that we could find because the reactive takes an expression. We're going to call this reactive this soccer matches to kind of specify that it is about this country. Yeah? And we're going to create a reactive out of that. This reactive will make use of the soccer matches data. So since this object is defined globally, on top of the app.r file, it will be known here as well. What we want to then do is we want to filter this particular data. And we want to filter to be sure that the home team is equal to whatever country we have chosen. Thank you. For whatever country we have chosen. And in order to do that, we also, again, similar to here, the page name, we need to have a particular variable for that. So chosen country, we would call that. Also, we want to make sure that the away team, this is home team, by the way, that the away team is also equal to the chosen country. And then what I want to do here is I want to arrange the data so that the latest match is on top. Otherwise, we would need to go all the way back to see the latest match. So descending on date. Okay, since we're using chosen country here, we would also need to specify it as an argument in the country page server. So similar to how we did that in the module UI, we can do it here with chosen country. Okay, So we now have our reactive, and we can use the reactive to display some text. So we could say, hey, we have an output here. We called that output general info, and I'm going to assign it a value. Now, just like magic, Shiny will know that this thingy is belonging to this thingy. You don't need to wrap this in NS. Shiny is smart enough to figure that out themselves. This NS is only relevant in the module UI. Here you can just, as you would do normally, leave it as general info, and Shiny will figure that out completely on its own. We're going to use a render text function here to display some text. And I had a very fancy sentence in there with country has played so many matches in total. The first match was on this date and that date, blah, 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 blah. But I'm going to keep it a little bit simple for the sake of time. And I'm just going to display the number of rows that are in this soccer matches. Just to keep it short. So just the number of matches that have been played by this particular country. Now we also have a table. This table is a DT table, and that was called the matches table. We're going to do render DT, similar as that we do with render text, and in that we're going to display a data table. And we're also going to use our reactive for that. So we have this soccer matches, and what we could then do here is we could select all kinds of arguments that we would want to, but I'm not going to do that. Too much typing at this point in time. We're going to just turn it into a data table so that it can be displayed. Okay, so that is our country page server and our country page UI. Now, obviously, we want to display it whenever we select a country. More specifically, we want to dynamically call our modules. And that means that whenever the button is being clicked, we want to do something. So I'm going to head over to our main app, so to say, and to our server part. So this is our chart, our e-charts. I'm going to collapse that to make it all a bit more manageable. And what I want to do here is whenever this button is being clicked, so this particular button that is called generate pages, with input ID pages, I want to do something. And that something is calling a module. It's a side effect. Now remember from the first part of the workshop, if we want to have side effects, we could use observers. So in this case, we're going to call observe. And basically, we want to do something whenever that button is being clicked. So we're going to bind an event to that, to this input pages. Right, and now we're going to have a bit of content in there. So the side effect being is that we want to dynamically call the module UI and dynamically call the module server. Now, this is something that you need to know, but if you are dynamically calling a module UI, you need to use lapply, not a for loop. If you would do this with a for loop, it just doesn't work. So we're going to go down the lapply route. What we basically want to do is for the countries that we have chosen, because users can select more than one country, we have chosen countries, which is equal to whatever the user gave in this picker input. Now, this picker input has input ID country. And just to make it ourselves easier and not write input country every time, we're going to call it chosen countries. Now, for every country in chosen countries, we want to do something. So function this country. And more specifically, we want to insert into the navbar our country page UI. So what we're going to do here is we're going to say nav insert. It's from the bslib package as well. And what we need to do here is we need to say, hey, we have this particular navbar. I want you to add elements to it. Our particular navbar has an ID. Remember that we gave it the ID, navbar ID. Super original. Then we need to provide it with a target. So where do we actually want to put additional pages? And our target is going to be set up. Now, be aware here of capitals and stuff. Our setup is what we called this particular element in our nav menu. So we need to make sure that it's the same. So our target is going to be that. And what we are going to insert here is going to be in the nav argument. And what we're going to want to insert here is a nav panel. This nav panel will have a title. The title will be equal to this country. So that's coming from this lapply. And the content of this nav panel is, our country page UI. Now, our country page UI had a couple of arguments. Remember, going to scroll all the way up. Our country page UI had two arguments, namely the ID and the page name. So we need to make sure that in our nav insert, we're also going to give an ID. And the ID, that needs to be unique. Luckily, there's only, there are only unique countries in this picker. So we're going to use this country as an ID. And the page name is also going to be equal to this country. Note, since this is literally the same, what I also could have done here, if I wanted to be smart and not repeat myself, is not use this page name argument, but just use ID here instead. But I'm going to make myself a little bit harder. And I could, of course, cover it up by saying that I want to show you how to use arguments in modules. So the country page UI. So this is then going to be our nav panel that we're going to insert. The other thing that we need to provide here is a position. So this is part of the nav insert function. And the position is basically where we want to insert this new nav panel. And we want to do it after the target, after setup. Okay, so that is the module UI. Now, of course, we have the module server as well. So we have just nicely inserted it into UI. To make it all work, we also need to call country page server with this particular ID that is equal to this country. And again, we also added this useless argument, namely chosen country, which we also set to this country. Okay. So the big question is, will this work or will it not? Well, we'll see that. Did nobody say that I had a typo somewhere? Because it would be very convenient. No, I don't see any typos, so it should be good. So running this app, heading over to countries. And let's say I now select Albania and Algeria. I only select countries with an A today because they are at the top of the picker. And then we click Generate Pages. Then, moment of truth, if we now click on countries, we indeed see two countries added, Algeria and Albania. So, perfect. Let's click on them and actually see if they ended nicely. So, Algeria, yeah, we do have a nice H2. We do have here this number, which is a bit out of context here, but signifies 57 matches. And we have data that all seems related to Algeria. So let's see if that goes right at Albania as well. Well, perfect. Albania. Super cool. I hope this already makes you super excited for modules, because it certainly makes me very excited. But I think this is super brilliant. You just had to write it once and it's there. Okay, I quickly want to show you what goes wrong if I, for example, let's say, pick another country, Andorra and Angola. If I click generate pages now again, then something goes wrong, right? I have Albania in there twice, Algeria also, and when I click on them, no, we're not happy anymore because it doesn't work. That is because we have a namespace clash here. And to make that clear, I'm going to head over to the app. And what I want to show you here is that if we, of course, start adding again pages that we already added with the same ID, then something goes wrong. Shiny doesn't understand that. Shiny is super confused, and Shiny will just stop displaying it altogether. So what we would actually need to do is we would need to leverage our petite R strategy to solve this problem. And how? Well, first of all, by creating our little r, reactive values. And we're going to make sure that we keep track of the pages that we already added. So we're going to put in here active pages, and we're going to initialize it to null. Now, what we can do then here in our lapply, we could say here, hey, if this country, if I already did that at some stage, so if it's already in my active pages, did I call it active page or active pages? If it's already there, I don't want you to do anything. You know, we've been there, done that. We're not going to do that. So I'm just going to get you out of this particular iteration that you are in this lapply. Just going to return with nothing. And what we're going to do then there is, of course, we need to keep track of the active countries. So outside of our lapply statement, we're going to say, hey, or at least something where we would say our active pages is now equal to our chosen countries. To update kind of our active pages. So whenever this did run once, Albania and Algeria would be stored in active pages, and the next time we click it, they won't be added again. So that would solve this problem. Then there's also a solution that we could build in to remove countries. So let's say what happens if I deselect Algeria. I can add some logic in there. I'm not going to do that right now for the sake of time, but it will be in the final solution. But let's quickly check if this is actually working out the way that we want it. So setup, I'm going to choose Albania, Algeria, generate pages, is all working, super cool. Now, if I add another country, Angola, for example, then we will now see that we just have 3 countries and not, how many were there? 5, 6. And if we click on them, then it now is all looking perfectly fine. Okay, good. I quickly want to check in with you if there are any questions, and if you are actually feeling like, yeah, I could do this, you know, modules, yes, kind of makes sense. I see this happening. If not, also feel free to let me know, because it can be a hard topic, especially in the beginning. It requires some practice, but hopefully the templates that I have for you as well will actually show you or give you a quick start, you know, to make that happen. The final code will be shared immediately after this workshop, and it will be in the ShiScores folder. I have the full code ready for you. There's one last thing that I want to show, because we still have 15 minutes, and I do really want to show you that, because that's one big struggle point. Sharing data between modules. That's really the number one question that a lot of people ask. How do you share data between modules? And how can you make sure that information you gather in a module can be used somewhere else? As I said, the Petit R strategy is great for that. So I quickly want to make something with you that will make it happen. So how cool would it be that if you are in a particular module, that you would have a button, or no, let me rephrase that. If you are at a particular country, let's say Albania, that you could say in Albania, this is my absolute favorite country. This is my top team. This is my favorite. So let's say we have a little button there. And this button could be a favorites button. And then in the main app, we would want to display or keep track of what our favorite countries are. So let's quickly do that. To do that, first of all, in the module, we're going to add, after the H2, a favorites checkbox. I'm going to use a super cool checkbox for this, which is called the Pretty Checkbox from Shiny Widgets. It has an input ID that is called NS Favorites. It has a label. This is my fave. And it has a value of false to start with. A status of warning. I'm sorry I can't run through this with you, line by line, but do check this package out. Status warning, and I'm going to give it an icon. This icon is going to be a star. And then I have some other settings here to make it look good. Plain is true, and outline is true. Okay, so I have this button here now. Quickly going to show you what it looks like. Countries, going to add one country this time, Albania. Now we have here this checkbox. If I click that, well, awesome, little star. I absolutely love this. Shiny Widgets has a lot of gems in there. This is one of them. Super cool checkbox. So you could mark this as this is my fave. What I would want then here in the setup page, let's say below this button, is a simple text displaying, hey, these are your favorites at this point in time. Now this button is in a module. And this setup page is in the main app. So how do they communicate with each other? Well, you know that answer by right now. It is with the Petit R. So first of all, what we're going to do is we're going to make sure that our country page server can make use of that Petit R. So we're going to pass an additional argument here, namely the Petit R. What we would then need to do here as well when we are calling the module dynamically, namely in our lapply, we are going to add another argument. How cool is it that it is already telling me that? R is R. Now, what we are then going to do in our country page server is we want to give some functionality that whenever the checkbox is being checked, that we are going to update our R favorites entity. So in our Petit R, besides active pages, I'm going to add favorites here, which I initialize to null as well. Then here in this server, sorry, I'm going back and forth a little bit. Here in this server, we're going to put an observer, because the side effect being that we want to update our reactive values, our Petit database, and we want to say something like, hey, I have a current favorite, so to say, and those current favorites are actually whatever is currently in my Petit R. I'm going to show you here something special. Something is called isolate that you didn't hear about before. Isolate makes sure that our observer doesn't trigger on this reactive input. I can't go in full details about what it is, what it entails, but it basically stops reactivity. And that's sometimes handy because what we're going to do in this observe is we're going to update our reactive object with a new value. If our observe is dependent upon that reactive object, we will end up in a loop. Because if we update it, the observer gets triggered again, then we update it again, the observer gets triggered again, and that never stops. And that's super annoying, and we don't want that, so we put it into an isolate. So we say favorites. So these are our current favorites. We start off with 0 or null favorites, so the current favorites value will be null as well. And what we're then going to do is whenever the checkbox is being checked, so whenever our favorite checkbox is being checked, we're going to update our favorites. And it will be a combination of our current favorites and the chosen country. Chosen country, remember, is equal to the ID, basically. So our favorites will be a combination of all the country names. If we didn't check that box, we obviously want to remove it, perhaps from our favorites. So we're going to say our favorites is our current favorites, and then our current favorites, we're going to index it. I would encourage you to look at this code a little bit later as well, just for the sake of time, because I really want to show you this. I'm going to go through this quite quickly. Oh, that's not cool. Okay, then don't autosave. Okay, that. What I'm also going to do here is I'm going to add a requirement, because the Shiny widgets the Shiny widgets checkbox in our particular case is actually initialized to null. When this is null, when this value is null, the if statement would fail. Technicality, you just need to try it out what happens if you don't do this. Because we're going to say, hey, I only want you to execute whatever is in this observe if it is not null. But do feel free to play around with this and see what happens when you don't do that. Okay, in our main UI then, in our top level app, we're going to add a text output. So below that actual button here, which says generates pages. This text output will have an ID, which is called favorites. And what we're going to do then here in the main server, so we are going to connect this observe with the lapply. We're going to say, hey, this text output is going to be whatever is in our favorites. To keep it quite short, and I need to wrap it in render text. Otherwise it will film. In the final version, I have a nice little sentence here, but again, for the sake of time, I'm omitting that. Okay, so let's run that and see what happens. So I'm going to add my country now. I'm going to add a couple random generate pages. Now I've got a lot of pages now. Andorra, that's going to be my fave. So I'm going to tick this button. Now, if I'm going back to the setup page, we see Andorra there. And if I put, let's say, Algeria is also my fave. And I'm going to the setup page again, we see Andorra and Algeria. So, yay, very cool. I went through this super quickly. In the final example, it all looks a little bit more polished and stuff. But this is how you share data between not only modules and your main application, but also other modules. This petite R, you can literally pass it through any module and you can use it everywhere, which is, of course, super convenient. Do keep in mind that this makes your modules less transferable, so to say. Normally, a module is very self-contained. It is its own mini app. But what we're doing now with this petite R strategy is we're pulling data from the outside. It's like you're kind of requesting additional arguments, but this R could have literally anything. So you need to document that very well. And let others know what you are expecting to be present in this petite R before it can actually be used. Okay, so this was basically, well, not entirely it. I'm going to see if I can find my slides again. Of course, always losing them, so annoying. Oh, yeah. And I'm going to head over to the end. Good. Right. A little recap of what I hope you have learned during this workshop. You've learned how to create your first Shiny application. You learned how to use inputs, outputs, observers, reactives, reactive values. You learned how to read in data and what this global section is about. You learned modules and sharing data between modules. And I honestly think that's a lot for 2.5 hours. If you were completely new to Shiny before this workshop, I can pretty much understand that it is overwhelming. Don't worry, take your time to look back at the examples. This session is also recorded, so you can also look it back at any time if you want to replay certain sections. If you have any questions that cannot be answered or were not answered in the chat, feel free to open an issue in the GitHub repo, and I will come back to you, not tonight, because I'm going to bed, but tomorrow. And then I will be happy to help you out there. Then I quickly want to mention that your Shiny journey doesn't end here. It's just getting started. You just need to practice, and if you have fun developing your Shiny applications, then it will all be all right. If you want to keep learning, I have a course that is just launched, or it's actually now in pre-sale and is launching next month. It's called Productionizing Shiny, and there you can enjoy me for 20 hours of video content. So if you're not having enough of me after these 2 hours, but want to hear more, then this course is for you. And this will cover basically everything from basic Shiny to testing to deployment, basically the full Shiny workflow. Okay, if you have still any questions, as I said, the GitHub repo is probably the best place because we're kind of running out of time. And I think David did a brilliant job with answering all the questions. So I want to thank you very much for your participation. David, in particular, thank you for assisting me with this workshop and covering everything in the chat. I hope you had a good time.
Yeah, it was great. And if anyone has any more questions for me, you can reach out in the Shiny for All Slack workspace, and I'm always on there. So just feel free to let me know.
Great. Well, thank you all, and well, have a good day or a good night or a good morning or wherever you are, and see you next time.
Bye, everyone.
Bye-bye. I'll keep around a little bit longer in the chat to see. But yeah, I really I think it was a good session, and a lot of people as well, right?
Are we live? Can they?
I think we have a lot of Shiny developers after this this workshop.
We had it maxed at 242.
Oh wow, yeah, it's a lot of people.
It stayed at about 230, something like that, until about 10 minutes before the session ended. So that's an amazing retention rate. Yeah,
that is it. I think we have a lot of new Shiny developers here.
Yeah, I hope so.
Yeah, I'm going to push the materials right now. I'm still going to do it. I'm going to sleep. I already had it finished, but there's the full app. It doesn't look much off from what we eventually did, but it's all a bit more, commented code and a bit more clean and stuff. So
did a great job. There was a lot of compliments in the chat.
Well, I'm very happy to hear that. I see some nice comments there as well. So yeah, thank you guys. Thanks a lot. it's obviously, of course, a success because you are all here. And I hope you enjoy tomorrow and the day after with the main conference talks. I'm already pretty much looking forward to a couple of talks, one from Joe Chang, which is about the extended task feature in Shiny. So I'm super excited for that. And of course, it's hard to choose with all, all those speakers. Okay, well, good. Thank you, and see you. Bye-bye.